Hi, everyone. I'm Nikhil from Google, and I'm here with my colleague Greg. And we are going to talk about Multicluster Ingress powered by Kubernetes Cluster Registry. There are a lot of powerful words there, so we'll try to break it down for you. The way we are going to structure this talk is we are going to start with, before diving into Multicluster Ingress, we'll just give an overview of why people run multiple clusters and what does it mean running multiple clusters. And then we'll go deeper into specifically Multicluster Ingress. And then we'll also talk about a command line tool we have in the open source called kubemci. We'll give you a short demo of that and how you can use that to create multi-cluster ingresses. And then Greg would talk about cluster registry and how we can build controllers over cluster registry. And with that idea, how we can do multi-cluster ingress and provide more magic about by using multi-cluster ingress using a controller with cluster registry. And we'll do a demo at the end. Feel free to ask any questions as you have during the talk, or in the end, we'll have some time for Q&A as well. So there are a lot of reasons why people run multiple clusters. We've highlighted a few here. The most common one we hear is high availability. People want, even if one cluster goes down, they want to be resilient to zone failures or cluster failures. Even if one cluster fails, they want to deploy their app to multiple clusters globally in US, Europe, Asia. Even if one cluster goes down, they still want to be able to serve their customers. So they want high availability, and that's a common reason to run multiple clusters. Another reason is for scalability. Sometimes one cluster is not enough. They want multiple clusters. Customers want to avoid vendor lock-in. They want to have clusters on-prem, on cloud, different cloud providers, easily be able to switch across them. They want geo-proximity, so they have global customers all through the world, like in Asia, Europe, US. They want clusters close to these customers so they can serve them better with least latency. There are a lot of other reasons as well, but these are some of the common ones we hear, and I hope you connect with them. Once people run multiple clusters, there are a lot of problems they run into which they don't have with single clusters. For example, now they want to deploy their app across multiple clusters. They have to ensure that they keep it in sync in all the clusters. Whenever they're rolling out a new version, they have to roll it out across all. And how do you do rolling update? Do you do it one cluster at a time? Or you percentage-wise, you roll on all of them and then gradually roll it to 10%, 20%, 100% across all of them together or one by one? How do you want to do it? When you're rolling it back, you want to roll back across all clusters. So how do you do that easily and build tools around that? How do you configure network resources? So this is something we'll go deeper into on this talk. How do you configure your services and ingress so that customers are routed to your apps which are already deployed in multiple clusters? So how do you do that? Now, or you have multiple clusters, you want unified policies across all of them. You want the same namespaces, similar RBAC rules. The same developers get access to all those clusters. You want to ensure the unified policies. You want failure domain isolation. Like I talked about high availability, that's one of the main reasons. So even if one cluster goes down, it should not affect other clusters. So you want multiple clusters, and you want to roll the same version across all of them, but you still want independence across all of these clusters. They should, if there's an error in one, it should not affect any other cluster. Each cluster should be able to work independently without the other one. So these are some of the common problems that people run into running multi-cluster. And there are a lot of solutions we are working on it as part of SIG multi-cluster. But in this talk, we are going to focus on multi-cluster ingress, which was the second bullet point. So a lot of times, people have a question of what do you mean by multi-cluster ingress? So taking a step back and going to the basics, what we mean by multi-cluster ingress is, and to explain that, we'll start with what we mean by single cluster ingress. So ingress is Kubernetes abstraction of the various load balancer providers that exist. So there's GCP load balancer, there's on-prem load balancer, there are other cloud provider load balancers. And in Kubernetes, we have our abstraction called Ingress. So users don't need to know about what GCP load balancer is or what their on-prem load balancer is. They write an Ingress spec and their Ingress controllers then which go and configure Google Cloud Load Balancer or Nginx Load Balancer, Envoy Load Balancer. There are all these Ingress controllers that exist for various load balancer providers. So what they do is they configure whatever the implementation load balancer is. In the end, users get an IP address, which they can give to the users, and users hit that IP address, and they're able to reach a particular service. So in this case, they want to reach service foo. So this is how they configure a single cluster load balancer. Extending the same concept to multi-cluster load balancer, now they have 3 clusters, A, B, and C, and they have the same service foo deployed across all 3 clusters. And they still want to be able to write one ingress spec and be able to configure a load balancer, which gives them one single IP address, which they can then go give to their customers. And customers can hit that IP address and be routed to any of these 3 clusters. So this is multi-cluster ingress. Why people want multi-cluster ingress? There are a lot of advantages. The most common one we hear is they want to do least latency based routing. So they want to have clusters where their customers are, so in Europe, Asia, Europe, all across the world. And they want to be able to have that single IP address, which then routes customers to the closest cluster. So when customers from Europe hit that IP address, they should be routed to Europe cluster. And when customers from Asia hit that IP address, they should be routed to Asia cluster. So that is one of the very common use cases we hear. Some other use cases are, like I said, they want to be resilient to clusters going down. So by default, Europe customers should be routed to Europe cluster, but if it's down, they should still be routed to other clusters. So rather than like they're seeing 404s, they should still be routed and be served, and which makes the application resilient to clusters going down. And now you can build global services based on this architecture. You want scalability. You can handle a lot more requests if you have the same app deployed across multiple clusters. If it was only in single cluster, then you run into some scalability limits. You might want to canary clusters, and you want to canary new Kubernetes release versions, or you want to canary your own deployment. You want to do blue-green deployment. So by keeping multi-cluster ingress, you have like a new Kubernetes version comes up. You can switch 5% traffic to it, and then gradually increase it to 100%. Or just try it out in your dev staging environment, and then switch. And rolling back is easy. So you can do canarying clusters using multi-cluster ingress. People want hybrid setups as well. They have their own data centers, and they're moving to cloud, or they are across multiple clouds. So multi-cluster ingress helps enable them when they deploy their app across multiple cloud providers or on-prem. They can still get a single IP address for all of those apps. So these are some of the advantages people get with multi-cluster ingress. So the problem at our hand is people have an ingress spec, and they have a list of clusters. And then how do they configure a load balancer to get this single IP address that can route traffic to all the clusters? And there are various ways to do it. One of the way we do it is using this kubemci CLI, which we've open sourced. And this works today, so you can try it out. The way it works is you run kubemci create, you give it a load balancer name, you give it your ingress spec, which is your standard Kubernetes ingress spec. You give it your cluster list, which could be your kubeconfig. Kubeconfig already has a list of clusters, so you can use that to give list of clusters to kubemci. And what it does is it configures. So today it talks to Google Cloud Load Balancer and configures Google Cloud Load Balancer for least latency mode. So I talked about what are the various ways you can use multi-cluster ingress. The default mode way it works is the least latency one. So it sets Google Cloud Load Balancer in such a way that users from, like in this example, for example, Alice from California would be routed to US cluster, and Bob from Berlin would be routed to Europe cluster. So I'm going to show a quick demo of how the CLI works. And I hope it works. So for my demo, the setup I have is I have 2 clusters, one in Asia and one in Europe. And this is my kubeconfig file. So I'm just listing the context in my kubeconfig. So kubeconfig.yaml has 2 contexts, cluster Asia and cluster Europe. And so I'm going to use this kubeconfig to create my ingress. So kubemci has the simple create command. And all I need to pass to it is I give a name. Here I give new kubemci zone printer. I give it my ingress spec and my kubeconfig. So just those 2 things. And it'll go and configure Google Cloud Load Balancer to send traffic to these 2 clusters. So if any of you have tried configuring Google Cloud Load Balancer, there's a lot of steps you have to do. You have to configure health check, backend service, firewall rule, forwarding port. So this would go and do all of that. It'll print when it's done with the health check, with backend service, with firewall rule. And hopefully at the end, it'll say success if it works correctly. So once it's done, what we'll get is we'll get a single IP address that then we can hit from all across the world and be routed to different clusters based on our location. So we'll see if that works. Wow, it said success. So I can list my ingresses with kubemci. So kubemci has a simple list command. And when it lists, so you see we created our new ingress, the new kubemci zone printer, and we see it's there. For this demo, I'll also use this existing kubemci zone printer. It takes some time to configure the load balancer, and just to save time, I'll use the existing ones that I already have. So I'll use the IP address of that existing MCI that I have. kubemci also has a get status command, which gives you information about the IP address and what clusters is it spread to. So I'll use this IP address 35201. And let's see. So I'm going to use this thing called GeoPeeker. What it does is it hits that IP address from different parts of the world. I hope it works. I'm using the free version of this service, so there's some latency. But hopefully it works. So it's going to hit the same IP address from Singapore, Brazil, Virginia, California. And so I have 2 clusters, Europe and Asia. So you can see when I hit it from Australia and California, it went to the Asia cluster, which is running in Tokyo. When I hit the same from Brazil and hopefully from Ireland as well, it should go to Belgium cluster, hopefully when it loads. So you can see from all around the world, users can hit the same IP address, and they'll be routed to the right cluster. So that's the great thing we get with kubemci. Okay, so we have this working. So what I want to show next is, we've been able to make multi-cluster ingress work with kubemci, but it's still a separate binary that you have to install, and you have to configure it to create multi-cluster ingresses. I think we can do a lot better, and that's where Cluster Registry comes in. And I'll invite Greg to tell us about Cluster Registry.
Hey, all right, thanks, Nikhil. Yeah, so I'm Greg Harmon. We're both on the multi-cluster Kubernetes team at Google. So I'm going to talk about Cluster Registry. So the motivation here is when you have multiple clusters, you have to keep track of them and deal with a bunch of kubeconfig files. Maybe you have a bunch of clusters in one kubeconfig, or you have a handful of kubeconfig files. Then let's say you add a cluster or you remove a cluster, then you need to update those kubeconfig files. You're working on a team, then you need to get those updates to your teammates, the other devs. So maybe you have something like it's on NFS, or maybe you check it into Git. But so there's kind of ad hoc solutions right now for dealing with multiple clusters. Maybe if you're more advanced, then you have some homegrown tooling around how you deal with clusters and their kubeconfigs. So what we're building is the cluster registry. It is basically a list of clusters as well as associated metadata. Each cluster can have labels, so you can have them as test, staging, prod, etc. And these let you do standard Kubernetes label selection. It's just part of the metadata field. And because it's a standard Kubernetes API, that means you can use the existing tooling you're used to using for workloads, like kube control. And this is kind of meant to be a building block that you can build other developer tools on top of. So here's a YAML file with a cluster and cluster list objects. You see it's basically got the name, US West 1A. It's got the endpoint. It's got the certificate for the endpoint. And you see right now it's in alpha. We're working on bringing that to beta in the SIG multi-cluster. So that's happening pretty soon, I think. So when you have a cluster registry, it's pretty straightforward, right? You have a cluster object. It lets you basically CRUD your clusters. So what if we put it with a regular Kubernetes API server? Then you can have it with all your other resources. You have ingresses, services, and all the other standard resources. So this lets you build more complex use cases and lets you have your cluster list side by side with the rest of your Kubernetes resources. So one of the big value adds of Cluster Registry is running a controller with it. When you have a controller, you could watch the list of clusters. You can watch other resources in that API server. And you're probably going to want to watch these resources in each of those listed clusters. So here in this diagram, we have the foo controller. It's watching the cluster list and foo resources, and it's replicating that foo to a subset of clusters based on some label selector that's not shown here. So you have replication is one good use. The other good use is logging and monitoring type things. So if you have, let's say you want to scrape a particular data value out of every cluster, you can aggregate that in a controller and be able to report that back sort of across all your clusters in one spot. So for the rest of this, we'll focus on the MCI controller. This watches the cluster list as well as the ingress resource in the K8s API server. So what it does is it basically ensures that all the clusters in the cluster registry are part of a load balancer. So it programs the load balancer API. And when a cluster is added to cluster registry, the controller sees this as a notification and updates the load balancer to say, hey, add my new cluster to the load balancer. And just like that, you get spread to the next cluster. Similarly, if you remove a cluster, the controller sees that and automatically updates the load balancer to remove that cluster. You also have the health checks in GCP load balancer that would notice that cluster going away if it were to just disappear. Yeah, and the last thing is that it watches ingress. So if you need to update your ingress specification, then that can also get pushed, will also get pushed to each of those clusters. So over the CLI, you don't have to invoke this manually. It's just always running in the background for you. So it makes it a much more automated way and much more like Kubernetes-style. So Nikhil is going to demo the controller we've put together.
Awesome. So now we know how we can build this multi-cluster ingress controller with cluster registry. And let's see how we can do it. So I'm going to show a demo. And before I start, I'd like to thank Rohit, who built this demo. He works with us at Google, and thanks for building this demo. Hopefully it works. So for this demo, the setup we have is I have a kubectl that is configured. Sorry?
Ask them if they can see that.
You guys can see this? Great. Awesome. So my kubectl is configured to talk to cluster registry. The setup I have is I have a cluster registry, which is running in aggregated mode, the second architecture that Greg showed. So now, using the same API endpoint, I can list clusters as well, and I can CRUD normal Kubernetes API resources as well. So in this case, I would CRUD ingress. So first, I listed my clusters. I have 3 clusters, one in Asia, one in Europe, one in US. I have global presence. I'm using GKE. And so I'll then create an ingress. So just to show what my ingress looks like, this is a standard Kubernetes. Even if you were doing a single cluster ingress, this is how it looked like. You give it an IP address. You give the service that you want to expose. So in this case, I'm exposing the zone printer service. So it's the same example I used in the earlier example. What the zone printer app does is it just prints the location where it's being served from. So when I hit my IP address, the request goes to one particular cluster, and as a response, I get the location of that cluster. Did that request go to Asia, Europe, US? Which cluster did it go to? So we'll be able to verify that it's working correctly. So this is my ingress, and as Greg mentioned, one of the advantage of running this controller as cluster registry is that I now don't need to download a different kubemci binary and run it. I can just use standard Kubernetes concept. So I can just run kubectl create ingress, and the multi-cluster ingress controller that is running, that is watching this cluster registry for list of clusters and list of ingresses. So it will see, oh, there's this ingress that has come up, and I have 3 clusters, so I should then go and configure Google Cloud Load Balancer to send traffic to all these 3 clusters. So once the ingress is created and Google Cloud Load Balancer is configured, we'll be able to hit that IP address from different locations and be able to see that we are routed correctly. So once I've created ingress, I can list the ingress to make sure it's created. And I'm using standard kubectl create get commands. So here again, you'll see this new demo zone printer ingress that I just created, but I also have an existing zone printer, which I'll use for this demo. So this is the IP address 35.201.67.42 that I'll use. And what I'll do is, so here I have two instances, GC instances, one in US and one in Europe. What I'm going to do is I'll call that IP address from US and Europe and make sure that I'm sent to the right cluster. So let's say I call it from Europe, and here my request is being served from Netherlands, where my Europe cluster is. And similarly, if I call the same IP address from US, it's being served from Iowa, where my US cluster is. So this is the same setup as we saw before. Like now, I have the single IP address that I can hit from all over the globe, and I'll be routed to the same IP address. But controller has some more advantages as well, and we want to show you those. Once I have this setup working, the advantage is that it's always watching the list of clusters and ingress, and whatever changes I make, it'll be able to observe that and update GCLB as per those specifications. So let's say, what if I want to delete a cluster, or like I delete the app in that cluster? So in this case, let's say delete the US cluster. So I list my clusters, I have those 3 clusters. I'll delete the US cluster. So what happens is that the multi-cluster ingress controller that is running observes that, oh, that this cluster is now deleted, and I need to update the GCLB that was configured to send traffic to 3 clusters. It should now send it only to 2 clusters. Like I'm running this kubectl get clusters command. The controller is also always running that command and watching that now there's only 2 clusters. So what should eventually happen is this curl command that we were running, that was the request was being sent to Iowa. We'll see that it starts detecting that that cluster is down, and now my request would be routed to other clusters. And you can see how seamless this was. Like as a application developer or anyone who was maintaining this ingress, they didn't have to make any change. Like whenever the cluster list was changed, the controller automatically observed it, updated GCLB, and to my customers, it was all seamless. Like they didn't see, like US cluster was down, but they didn't get to see that a cluster is down, or they didn't get any 404. Their request was still served, and now they're being served from Netherlands and Tokyo, and eventually it will settle down to, once all the BGP routed the propagation is done, they'll all be served from Netherlands. So like this is amazing. My customers didn't even get to see that the cluster is down, and I didn't have to do anything. It was all automatic. It figured out and updated it to send traffic to other clusters. And this was for deleting clusters, and same thing. Now you figure out the problem, you debugged it, and you want to, again, add back the US cluster. And the same thing works for adding back as well. You add new cluster, or you create in this case, we'll create the US cluster again. So we have 2 clusters. I'll create my US cluster again. And now if I list, I get 3 clusters. Similarly, when the controller lists, it will get 3 clusters. And if I go to my US instance, it will eventually start serving traffic from US cluster. So when you'll observe, it takes a while. When we deleted a cluster, it was instantly, it started sending traffic to other clusters because like that cluster was gone. When a new cluster comes up, it still takes time it makes sure the health checks passes for sufficient time, and then it verifies that it's stable, and then it starts sending traffic to the new cluster. Yeah.
Is it actually deleting and recreating the underlying cluster?
No, this is not managing the clusters. This just manages the ingress and GCLB, so that GCLB stops sending traffic to that cluster. Yeah. So I just deleted cluster from the cluster list. Like that cluster still exists. If I go to GKE and list my clusters, it exists, but I removed it from cluster registry so that my ingress controller is watching cluster list and cluster registry. It doesn't get that. Yeah, so you'll see eventually it started sending traffic again to Iowa back. So as an application developer, I didn't have to update my ingress spec or anything. It automatically happens. So like this is the real power. Sure.
Is the single annotation you had in the ingress the thing that tells your new custom controller to include that ingress in the global cluster, or was that unrelated?
No, so the annotation was just to give it an IP address. So it needs an IP address to be able to send traffic to all clusters. And in the standard ingress spec, it's specified as an annotation, so that's why I was using an annotation. But there's no special annotation to tell that it's a global ingress. Like I created it in my cluster registry And so multi-cluster ingress is watching all ingresses in cluster registry, and it assumes that all ingresses that are created in cluster registry have to be spread to all the clusters that are registered with cluster registry. Yeah. If you wanted like a single cluster ingress, then you directly just create in that cluster, and that works as well.
The controller that you're using for the demo, is there any reference to that in the cluster registry repo?
No, this is just a prototype early version that we built for this demo. Rohit did. Yeah. Yeah.
Can the load balancer health check all the way through to the services in each cluster, or do you have to manage?
No, it does. So that GCLB supports by default that it health checks the apps directly, and if a pod goes down or anything, the service goes down, then it will stop sending traffic to them.
So is there one GCLB per service?
Is there one GCLB per? No. So you configure GCLB. There's an IP address per like load balancer, and you configure like forwarding rule, firewall rule, backend service, all the GCLB resources that you need to configure. Yeah.
You want to log back in and put the resources
Okay.
on.
Yeah, we are actually done with the demo, and it's time for Q&A. So, yeah.
So in your demo, there are 3 ingress controllers, right? One for each cluster.
So, yeah. So the clusters that I'm running, those are like standard GKE clusters that already have ingress controllers running. But I do have a multi-cluster ingress controller also running in cluster registry, which is what configures GCLB.
So that runs in one of the clusters.
It's
The multi-cluster ingress controller.
Yeah, it's running with cluster registry. So like I have a place where I'm running my cluster registry. I'm running this multi-cluster ingress controller there as well. And multi-cluster ingress controller watches cluster registry for list of clusters and list of ingresses.
Okay, so how is it? Is it HA or?
So for this demo, it's just like running, yeah. But if you want to run it on a production service, yes, you run it as HA. You can run it on a Kubernetes cluster or like wherever you want. You can have HA setups, yes, and you should have.
So additional question. So can I play with this with an Nginx ingress controller?
So this particular demo configures Google Cloud Load Balancer. Yes, you can write an implementation that instead configures Nginx to do the same thing. Yeah.
Okay, thanks.
Sure.
In one of previous talks, they were talking that. In one of previous talks, there was idea that this cluster registry, together with some controllers, will be like a replacement for cluster federation because it doesn't have some security stuff. But what I see here is it's more like just a copy of the same resource on different clusters. So you cannot really schedule like 70% on one cluster and 30% on. So is there still a plan to do it replacement, or maybe more advanced controllers are needed, or this multi-cluster primitives are needed per every? What's your?
Yeah, so that's a great question, and we hear from a lot of customers that they want like more advanced load balancing modes. Like in this case, there was just this where you send to all the clusters and you do like least latency based load balancing mode. There are other load balancing modes like you said. So, and yes, the API spec today does not support it, so it's not possible for the user to specify it. But we are discussing with SIG Network and other interested, and there's discussion happening in SIG Multicluster as well about how to extend the API to be able to support more advanced use cases.
It's not only about load balancers. I thought, maybe I misunderstood, but I thought that this approach will be used also for namespaces and for everything.
Yeah, so you could use it. Like Greg was mentioning, we want to build cluster registry as a building block that you can integrate with others as well and other tools that you have. Like maybe you integrate it with your CI/CD pipeline and you just want a list of clusters, or you want some other resources. So it has like a CRD as well. So you can install a CRD and do your own custom like multi-cluster specific resources as well. So you could do that. So it is flexible enough to be able to do all of that stuff. Yes. For this demo, we were just using the existing Kubernetes API.
Yeah. Hi, great demo. But I have a question related to the cluster registry. How does it help, let's say, the process running in one cluster, in cluster mode, to access API objects in the second cluster, like in terms of the security?
Yeah. So for this particular use case and in this demo, we didn't have that requirement, and it's not able to. Yeah.
But is it possible? Does it help? Does it provide any mechanism or some tools?
Yeah, no. So another thing about cluster registry is that it doesn't store the auth information about each cluster. It stores the list of clusters, and it has pointers to be able to point you to the right credential store. Like it will tell you it's a GKE cluster, and then you can run gcloud get credentials to be able to get credentials.
But then for a controller, basically to watch for objects in different clusters, I mean, you have to have a RBAC rules and the service accounts,
Yes.
how it's done if you have a multiple clusters.
Yeah, so in this case, the multi-ingress controller that's running does have access to all the clusters, so it has service accounts for those clusters.
Okay.
But each of those clusters don't have service account for other clusters.
Since when, what version of Kubernetes do we get this cluster?
It's already open source, so it's on. So we should also, yeah, it's part of Kubernetes/Cluster Registry, and you can go and try it out today. And the API is alpha. We want to move it to beta. So these are some of the pointers. You can go look at it, and it's outside k/k, so it's not tied to one Kubernetes release.
Do I have to populate the registry with all the... Do I have to populate the registry manually with all my clusters, or is there something like a gossip-based auto-population or self-discovery of multiple clusters?
So it's a standard Kubernetes API. You can use kubectl, and that's what we were using in this demo. But it has a REST API, so you can write wrappers on top, probably export your kube config into this cluster registry automatically. So it has the Kubernetes API, so that's the advantage. You can build all these tools on it. There's none right now, but it's easy to build them. Yeah.
Regarding the load balancer, is it actually routing all the traffic, or is it redirecting? I mean, is it any benefit in terms of network latency that you, let's say, direct all the Asia customers to the Asia cluster? If they all go through the load balancer anyway, they would get routed, let's say, to the US for every request.
Yeah, so that's the advantage we get with Google Cloud. It has worldwide presence, and what it uses is an Anycast IP, which is propagated through BGP routing to everywhere. So Asia customers are not actually coming to US. They directly go to Asia clusters via BGP routing. That IP address is propagated to Asia and Europe and US. That same IP address. That's the advantage you get with GCP network. Yeah. Awesome. Are there any other questions? Sure.
Do you have any thoughts on policy-based routing, say I don't know, a European user of a service who goes overseas, say to America, and their data is located within Europe, can't be exported to an American cluster, so their traffic always gets routed back to Europe?
Yeah.
Would this be a thing that you would solve at this level, or would you push that into the application?
Yeah, so I don't have a particular opinion about that, because once it comes to legal issues, this does try close least latency, but there's no guarantee. And if you have a legal issue that user shouldn't be routed out of Europe at all, and even if they go to US, they should still be routed to Europe, there's still some more logic that's required to build on top of this. So it is possible to do it in your application as well, or outside.
I would say it would take a lot of smarts from the load balancer to be able to do that, because you'd have to have some sort of key or hash from the user to know where to route it to. So that would take a lot of technology, I think, to make that happen.
Yeah. GCLV does support cookie-based routing, so that is something you could explore. But yeah. Thank you.